Alright, so apparently I hit my time limit there. It doesn't tell you when you hit it, and I went on teaching. I made it 10 more minutes of it not recording me. So I'm going back to this. So if you have not already watched video number one, start with video number one, watch that one, and because if you come in halfway through, you'll have no idea what I'm talking about, and things won't make sense. Watch video number one first. I'm assuming you've watched number one if you're still here, so let's jump back into it. Let me hit present. So we're doing this who done it, right? I just finished going through the different tracks, right? So the butler's the green, the cook is the gray, the maid is the two parallel white lines, the handyman is the thin white line, and the nephew is the red with the dog. Okay, so that's where the video cut off. So what we're going to do here is we're going to use the principles of geology, specifically superposition, to figure out what happened at the scene of the crime. This is what CSI, but this is what they do on TV. This is what crime scene investigators do in real life. They look at the clues, they look at the evidence, and try to put together a picture of what happened, and figure out what exactly happened at the scene of the crime. Now, this crime is pretty serious. This is an especially heinous crime of stealing the last cookie in the cookie jar. Now, the last person to leave the scene is the culprit. So, let's work through this and figure out what was the order that people left in, using using the principle of superposition. It's not a law because it's not backed by science. If it was a law, superposition would be true every single time. There'd be an equation that backs it. It's not a law. It's a principle. There are exceptions. It's not backed by mathematics. Okay, so it's a principle of geology. Keep calling it a law, but it's not. Okay, so let's do this. By looking at this picture, you can probably figure out the order that they came in. You may have already done it, but I'm going to go through it anyway. What order? Who was the first person to leave the scene of the crime? Well, how would you know? The first person to leave the scene of the crime will be the tracks on the very bottom. The tracks that were there before all the other ones. The tracks that were put there first. That's how we know who was there, who left first. Okay, so let's see. The tracks on the very bottom appear to be the maid, the two parallel white lines with the car. The maid drives a car. You can tell that the maid left before the handyman on the bicycle because the handyman's track cuts across. It cuts through it. It's on top of the car, the tire marks, right? So the bicycle mark is on top of the car mark. The maid left before the handyman. The motorcycle. The cook rides a motorcycle. Well, the cook's tracks are also on top of the car. And the butler's tracks are also on top of the car. You can't tell that where the nephew fits in as far as, or in relation to the car's tracks because they don't ever interact, but you can see that the butler and the nephew do interact, and the nephew is on top of the butler. So the butler left before the maid. The maid was the first one to leave. The maid's tracks are on the very bottom. Okay, maid left first. Safe. She's not the culprit. The second person to leave. Well, we'll use the same sort of logic to figure out who the second person was. Well, okay, so on top of all of them are on top of the tire marks for the car. So let's look at the rest of them. The motorcycle is on top of the bicycle tracks. The butler is on top of the bicycle tracks, and up here we've learned that the dog footprints, or that the nephew, are on top of the butler. So we can rule out the handyman. The person that stole the cookie was not the maid and was not the handyman. We know that those two people left before the cookie was taken. Okay. The third person to leave, well, that would have to be the cook, because the cook is below the butler, but on top of the handyman. So it goes maid number one, maid number one, handyman number two, cook number three. Butler number four. Butler's on top of these other four. We know that. On top of these other three. And actually, the butler's footprints are physically on top of the other three. Here, the butler's footprints are on top of the maid's track. Here, the butler's footprint is on top of the handyman's track. And here, the butler's footprint is on top of the cook's track. So we know that it goes maid, handyman, cook, butler. That really only leaves us one more person, right? The nephew with the seeing eye dog. That's who stole the cookie. We can tell. We know that the last person to leave the scene is the person who stole the cookie. And we can piece it together and figure out who the last person to leave the scene is, just based on the order of footprints. Now, like I said before, this is what crime scene investigators do. Now, this is a pretty simplified version, obviously, but this is what crime scene investigators do. Sherlock Holmes did this, right? This is what biologists do when they go out in the field and they're looking at tracks. Okay, this is, I deer hunt. I'm not very good at it, but I try. I look at tracks all the time. I hike a lot. I look at tracks. I see what the tracks are. I see what animals are there, and I can piece together what animals are coming in. Not when, but in what order they're coming in by doing this. Well, geologists do this too. Here's an example of what a geologist would look at. Now, this is a figure. This is a drawing, right? But in real life, there are places that are exposed to, similar to this, not quite as blocky, but where you can see things like this. Then geologists look at it and do the same thing that we did here. We'll use the principles of geology to figure out what happened. Now, I've talked about why I like geology so much. Well, and I've mentioned this a few times. I like geology because you can read the rocks like a book, like a history book. A history book that goes billions of years farther back in time than our oldest writings, paintings, right? This is how we learn about us. Here's an example. We've got layers of rock. Okay. Oh, before we get into layers of rock, I should tell you cross-cutting relations. Principle of geology number 4. I didn't have a good picture for it last time on that slide, but here it is right here. Granite was here. Slate was here. Pegmatite then cut through the granite and the slate. We know this because the pegmatite would not form this weird slanty line and then fill in behind it with granite and slate. We know that the granite was there. The granite had to be there before the pegmatite could cut through it. Just like if you're going to cut apart your sandwich. You've made a very nice sandwich. And you want to cut your sandwich in half. You have to have a sandwich before you can cut it, right? You can't cut your sandwich before you have a sandwich. You can't cut the granite before you have the granite. You can't cut the slate before you have the slate. The pegmatite had to have come after the granite and after the slate. It's the only way the pegmatite can make this shape. Okay, that's cross-cutting relations. By seeing that the basalt, this basalt dike, I'll talk about what these are in a minute. We'll talk more about it later. The basalt dike cut through the granite. The granite had to be there before this could do that. It cut through the sandstone. Now, the sandstone had to be there before the basalt could cut through it. It cut through the limestone. This limestone had to be there before the basalt could cut through it. It does not cut through the volcanic ash. The volcanic ash is on top of the basalt and on top of the limestone, which means, according to the principle of superposition, the basalt is younger than the limestone, but older than the volcanic ash. See how that works? If it cuts across, it's younger than the ones it cuts across. Okay, let's go back to these layers. I'm going to attempt to piece together, and I'm going to make this up as I go. All right, so I've done it a few times, but my story changes each time just a little bit. I'm making this up as I go. I don't know the history of this place, this fictional place. I don't know what happened there. I wasn't there when all these things happened. This is millions or maybe even hundreds of millions, potentially even billions of years of rock record shown in one image here. We really don't know. But I wasn't there when it was laid down. Just like a crime scene investigator was not there when the crime happened. Instead, they're picking up clues and pieces, evidence. Here we go. Superposition. The law of superposition states that the layers on bottom are older than layers on top. Well, if you look at the bottom, there's two options, slate or granite. Granite was there first. I can tell you that much. And I know that because here on this edge where the slate and the granite meet, the granite is below the slate. Yeah, we don't know what's happening down below here. Surely the rock continues down below this picture, but we don't know what's happening there. So here in this section, we do know that the granite was there before the slate was there. So granite is the oldest in this picture. Granite was there number 1. Okay. Then we have a slate coming in. Slate's number 2. Slate is on top of the granite. Yeah, okay, there was also this erosional surface here, but I'm going to ignore the erosional surfaces for now. I'll come back to those. So granite was laid down, then slate was laid down. Then the pegmatite dike comes through. We call it a dike if it's a vein of magma working its way through the rock and then solidifying into intrusive igneous rock. Pegmatite is a type of intrusive igneous rock. Same as granite. Granite's intrusive igneous, slate is actually sedimentary rock, and then you've got pegmatite working its way through. Okay? Granite number 1, slate number 2, pegmatite number 3. Then you have an erosional surface, and then you have sandstone deposited. Sandstone's number 4. Okay, we know this because sandstone is on top of the slate, it's on top of the pegmatite, it's on top of the granite. Sandstone's number 4. Then we have limestone laid down. Limestone's number 5. We know this because it's on top of the sandstone. Pretty easy. It's younger than the sandstone. Then we have this basalt dike, which cuts through the granite. It's younger than the granite. It cuts through the sandstone. Then it cuts through the limestone. So we've got granite number 1, slate number 2, pegmatite number 3, sandstone number 4, limestone number 5, basalt number 6. On top of that, comes the volcanic ash, number 7. And then the shale and siltstone on top, number 8. There are 8 layers of rock. We know the order that they were laid in. So if you understand the principles of geology, you can piece together at least the order of what happened. And if you understand the rock cycle and the types of rocks that you're looking at, you can piece together a whole lot more than just the order that they came in, like a potential scenario. Now, I wasn't there when this was laid down, so I'm getting ready to go through this really fast, and I could definitely be wrong on what happened in this fictional place. But I know enough about these different types of rocks, and I know the order in which they were laid down, that I might be able to piece together one possible scenario of what happened in this region. So here we go. Granite is intrusive igneous. It was deposited underground, a big magma chamber, and it deposited underground this giant chunk of granite. And over time, the rock above it was washed away. I don't know why, but it was eroded away and exposed this granite. We know that it was exposed because there's an erosional surface here, where this was on the surface. Weathering and erosion was happening to the granite itself, breaking down, washing away, leaving this eroded surface. Okay. Then the slate was laid down in these nice thin sedimentary layers. Slate is a type of mudstone. It was laid down by like this silty, soupy, sticky, slimy mud. Okay, it was mud, terrestrial. It's not the type of mud that you get at the top of or at the bottom of an ocean. It's not the type of mud that you get, in a pond. This is like a estuary, maybe like the Everglades in Florida. Swampy slates. Okay, so you've got granite, exposed surface, and then slate was laid down in these nice layers. And then you've got intrusive igneous rock, pegmatite, working its way up. This is a vein of magma that's solidified. So somewhere down here, there's something volcanic happening. We have granite, which came from a giant magma chamber, solidifying. We've got pegmatite working its way up and solidifying. Maybe it even erupted. We don't know. It could have erupted. We don't know because it's been eroded away. That part of the rock layer has been eroded away. There's another erosional surface here. So we've got granite, and we've got the slate piling up, and we've got the pegmatite working its way through, but then we've got some erosion happening again. Well, because the slate is mudstone, we'll say it's potentially like a Everglades situation. It's swampy, mudstone, it's terrestrial, it's land. But the water level in the area is rising. The water level is rising over time, and what used to be land, swamp, estuary type area becomes a beach, and now we have sandstones. As the water level rose, we now have sandstone in this area. Beach. It's really nice beachy area. Sand being deposited, layer after layer after layer of sandstone. But the water levels continue to rise. You probably don't know this, but limestone comes from the middle of an ocean. It doesn't have to be super deep, but